All right, we're still on section 4.3. This is the third video, part C. Hopefully the last video for 4.3. Hopefully we can finish it up in the next 30 minutes. So we're talking about the properties of logs, which again goes along with properties of exponents. So this is going to be, we're going to look at three properties that we can use to rewrite logarithmic expressions in different ways, okay, depending on what serves our purposes. Okay, so you can go either direction with these three properties. If you go from this to this, that would be considered expanding it. And if you go from this to this, that would be considered compressing it or condensing it. Or a lot of times the instructions will say write it as a single logarithm or something like that. All right, so you can go either way, just depending on the instructions or depending on what serves the purpose that you're going for. So basically, if you have two logs with the same base and you're adding them together, you can condense that down into a single log and you multiply the arguments together. If you're subtracting them, so subtraction gives you a fraction, or vice versa, you can expand it into a sum of logs or a difference of logs. And then this rule here is just, it kind of goes along with, it kind of is like a corollary, which means it follows logically from rule number 1, that you can, if you have like an exponent here, you can also turn that into a coefficient over here, or vice versa, okay? Because basically what this is saying is you'd be multiplying a bunch of m's together. That would be the same thing as, you know, adding a bunch of m's together. Same thing, like, or actually adding together a bunch of logs, I guess is what I should say. Okay, so, all right, so using property number 1, we want to take from a single log and express that as a sum of logs. All right, so number 16, so that would be log base 2 of 8 plus log base 2 of 64. Okay, so that's all for using that first property. However, we can simplify this further because we can rewrite 8 as 2 to a power, and we could also rewrite 64 as 2 to a power. Okay. So 8 is the same thing as 2 to the 3rd power. And 64 is the same thing as 2 to the 6th power. So then this cancels. So you end up with 3 plus 6, which of course is equal to 9. So the final answer there is 9. So you always want to simplify as much as you can. So number 17, log of 0.2x. So the 0.2 is understood to be multiplying with the x. So we can just, if we want to write this as a sum of logs, we would do log of 0.2 plus log of x. Okay, and some of you might be wondering if, like, hey, isn't that a base of 10? Yes, it is a base of 10. But there's really no reason for us to write it. So it's kind of like if you just see like an x, you're like, hey, I know that's the same thing as 1x. But you're not going to write it that way unless there's some reason to, right? Or you could say that's x to the power of 1. But again, you're not going to write that unless, you know, there's some reason to. So there's no reason to write the base of 10. So it's more simplified not to write it for our final answer. Okay. All right. And then number 18, we have log base E of AB. So that's AB is the same thing as A times B. So that's going to be log base E of A plus log base E of B. All right. And then next, we have some where we are using the third property, which is basically we're just going to take the exponent, we're going to move it into the front and make it into a coefficient. All right. So log base A of x to the 4th power is the same thing as 4 times log base A of x. All right. And then this problem over here, which for some reason doesn't have a problem number next to it, that's okay. But we're just going to move this exponent here. So that's going to equal -8 times log base B of Q. Okay. And then number 20, we have log base E of the square root of A. So first of all, we need to write that using an exponent. There's not any exponent shown right now. So the square root of A, to write that using an exponent, that would be the same thing as A to the power of 1/2. And then we can move the power of 1/2 to the front and turn it into a coefficient. So that would be log base, or that would be 1/2 times log base E of A. All right, and then these next couple problems are using property number 2. So we have a log of a fraction and we want to write that as a difference of logs. So remember, the fraction turns to subtraction. Okay, so log base A of 76 over 13 will turn into log base A of 76 minus log base A of 13. All right, so it's the numerator log minus the log of the denominator. Log of the numerator minus log of the denominator. Okay, and number 22. So that would be log base E of A minus log base E of B. Okay. All right. Next page, we're going to be using multiple properties in each of these problems. Okay, express in terms of sums and differences of logs. All right. And we're also going to move the exponents down to make them coefficients whenever possible. All right, so first we're going to use the first property. So we have basically 3 things multiplying here. So there's going to be 3 separate logs. So we're going to have log base A of x cubed plus log base a of y squared plus log base a of z. All right, then we're going to take the exponents and move them down to make them into coefficients, and that'll be our final answer. So our final answer is going to be 3 times log base a of x plus 2 times log base a of y plus log base a of z. And that's our final answer. All right, and number 24, we have a fraction. So we know there's going to be some subtraction. So the ones that are on top, they're multiplying together. So those logs are going to be positive, and then the log for the denominator is going to be negative. Okay, so we're going to have log base b of x squared plus log base b of y minus log base b of b cubed. Okay, and then we're going to take this exponent and move it down here as a coefficient. And then over here, we will cancel log base b of b. Okay, all right, and then my next thing I write down is going to be my final answer. So I'm going to have 2 times log base b of x plus log base b of y minus 3. And that's my final answer. Alrighty, number 25. Okay, so let's see, we have ln. So this right here is ln. We haven't actually gone over that yet, so I probably shouldn't have it in this section. I believe we do go over that a little bit more in section 4.4, I think. But in any case, it's just a special type of log. It's the same thing as log base e, so that's ln. So if you see this, especially a lot of people think it's like a capital I-N, because, you know, if it's not written in cursive script like this, it definitely looks like that. But that is ln for natural log. So anyway, let's see, we're pretty much just treat it just like any other log though at this point. So in this case, the first thing I need to do is I need to change that cubed root into a 1/3 power. Okay, so I'll just keep ln, and then all right, so let's see here. So I'm going to take this, I'm going to say parentheses 5x to the 5th to the power of 1/3. Okay. All right, so now at this point, I kind of have two ways I could go. I could either take that exponent and move it in the front here, or I could distribute it. But I think what I'm going to go ahead and do is to move the exponent at this point. So, okay. So that 1/3 is going to be in the front. Okay. So 1/3 multiplied by the natural log of 5x to the 5th. Now, technically, I don't need the parentheses around 5x to the 5th. You'll see on the homework and stuff, they may not put them, but just makes me feel better, especially if I have like I don't know, a 5 and x to the 5th. I don't know why. It's not necessary, but like I said, it just makes me feel better. I like to practice safe math and always wear my parentheses. So now we can go ahead and expand the log into a sum of logs, okay? So we're going to expand this into a sum of 2 logs. Let's see, so we've got the 1/3. So the 1/3 has to be, that's why we need these brackets now, because now this is going to turn into, instead of just one term, it's going to turn into 2 terms. Okay, so it's going to be ln of 5 plus ln of 5 of x to the 5th, rather. Ln of 5 plus ln of x to the 5th. All right. And next we can go ahead. So now, see, here we couldn't move this exponent of 5 because the exponent of 5 was only applied to the x, not the whole thing. So now that we broke that up, we can go ahead and move this exponent of 5 into the front of that log only. Okay. All right. I wish I had left myself more space. Where do I want to put this? Okay. I'm going to just put it right here. Okay. And let's see. Okay, so 1/3 bracket ln of 5. I got a new set of pins today, so I'm going a little crazy with those. Okay, there we go. All right, and one more thing. So the last thing I need to do is I need to distribute my 1/3. Okay, so the 1/3 is going to be multiplied with like the coefficient in front of the ln. You can't multiply it with the argument because that's like locked up in there. So, okay, let's see if I can put this right here. Okay, so that'll make it 1/3 times the natural log of 5. And then I've got to multiply basically 1/3 times 5. So that's like 5/1. So that's just going to be 5/3. Times the natural log of x. And that is my final answer. So I've got 1/3 times the natural log of 5 plus 5/3 times the natural log of x. And that is my final answer. Okay. And make sure that you know that you could never like combine, you know, you couldn't add 5 plus 5/3. I mean, not that you would really want to anyway, but you couldn't because the 5 is the argument of the log and the 5/3 is a coefficient of another log. Okay. All righty. All right. So let's look at number 26. All right, so again, we have the cubed root. So I want to start by changing that cubed root into a 1/3 power. All right, so I'm going to have log base C of, so turn this into parentheses, y cubed z squared over x to the 4th, and then all of that is raised to the power of 1/3. Okay, so just like I said on the last problem, I can either move that 1/3, which is what I did in the last problem, or I could distribute it. So either way is just all fine. I think this time I'm going to go ahead and distribute the 1/3 power. So I'm going to multiply the 1/3 times each of these exponents in the parentheses. Okay, so I'm going to go ahead and do that. So log base C of, all right, so 3 times 1/3 would just equal 1. So that would be like y to the power of 1. So I don't really need to write that 1. Then 2 times 1/3 would be 2/3. And 4 times 1/3 would be 4/3. Okie dokie. So now I'll go ahead and break it into my sum and difference of logs. So I've got two things that are multiplying on the top. The logs for those will be positive, and then I've got the one on the denominator, so the log for that will be negative. Okay. So then let's see here. All right, I'll just go like this. All right, so hopefully I have, darn it. Let me see. I'm not gonna have, that won't give me enough space. Okay, go right here. All right, so I'm gonna have log base C of y plus log base C of z to the power of 2/3 minus log base C of x to the power of 4/3. All right, and then last but not least, we will move the exponents and turn them into coefficients. All right, so I think I'm ready to write down my final answer. So log base C of y plus 2/3 times log base C of z minus 4/3 times log base C of x. Okay, and that's the final answer for that. Alrighty. Okay. So we're at 24 minutes for this video. Oh me, oh my. There's no way I can finish this section in another 10 minutes or so. So it looks like there's definitely gonna probably be a part D. They did say shorter videos is better, so alright. To be continued in part D. Yep.